it's recording. Thank you. Okay. Expanded octets have more than 8 electrons. Sylvia, could you get the door for us, please? There's a lot of people out in the hallway. Thank you so much. When we draw the structure for PF5, for example, there is absolutely no way to make a PF5 without having 5 things attached to the P. Because remember, F only ever forms how many bonds? Fluorine? Chat with your partner about that. So what do you guys think? It only ever forms 1 bond. The other halogens can't usually only form 1 bond, but they can form more because they are in row 3 or below. Now, while we're speaking about row 3 and below, where is phosphorus? It's in row 3.
Wait, when you say row 3 or below, it's row 3, row 4, row 5, right?
Huh?
Row 3, row 4, row 5.
Yeah, row 3, row 4, row 5, row 6, row 7.
Is it because it gets more multiplied? Because like yes,
because the radius is larger and it can accommodate more electrons. That's the best I can explain it at this point in your chemistry careers. If you take some serious inorganic chemistry along the way, you'll probably get a better explanation than that, but that's all we need to know. Okay, so if we look at phosphorus, we get PF5, and since fluorine can only bond once, it has to look like that because everybody has to be stuck to the P. And how many electrons does that give phosphorus? That gives phosphorus 10 electrons. 2, 4, 6, 8, 10 electrons. How many electron domains? Chat with your neighbor about that. How many electron domains around phosphorus? This is super hard. How many? 5. Okay, so phosphorus has 5 electron domains. And if we look at the structure, I'm still having problems finding. I got to start sorting these into boxes. Ah, there we go. Okay. So we have P, F, 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 F. Okay, one at the top, one at the bottom, and then 3 around the middle like a little tutu. Yes? 3 around the middle like a little tutu. All right. Anyone remember what this shape is called? Brian, are you playing on your phone? What is this shape called? Feel free to get out your molecular geometry sheet.
It's not trigonal, bro. 1, 2, 3, 4. Yo, I'm like blind, bro. 5.
Okay, so what can you see from this angle? What shape do you get? From this angle, what shape do you get?
Triangle.
You get a triangle. And then if we turn it this way, what shape do we have on the top?
Oh, it's square.
1 side, 2 sides, 3 sides. 1 side, 2 sides, 3 sides. Okay? 1 side, 2 sides, 3 sides. There's 3 sides on this what shape? Pyramid shape. Yes? So, and then if we flip it upside down, we have a base that is a triangle, and we have 1 side, 2 sides, 3 sides. So, what do we call this? Trigonal bipyramidal, because we've got 2 triangle-shaped pyramids. Now, I'd like you to take a look at this little drawing of it here and see if you remember what we call the top and the bottom atoms. They are on the
What?
axis, therefore they are axial. So I'm going to put, let's see, maybe I'll put it in red. A for axial. Maybe I should put it in black because red doesn't show up very well. A for axial. E for equatorial. So 2 of them are axial, 1, 2, 3 are equatorial. So top, bottom with, what do we have around the middle? A little 2, 2. Okay? Top, bottom, 2, 2. And if we were to replace any of these ones on this with a lone pair, where would we put the lone pairs? Would we put them on the axis or on the equator? Would you rather go visit the North Pole and the South Pole and stay there for a while? Or would you rather go on a safari or go to Fiji? What do you think? It depends on who you are. Some people might actually find, like, going to the Antarctic really exciting and stuff. For me, I'd be like, it's way too cold here. I cannot deal with it. And I actually did go a few years ago. I did go on a safari in Tanzania, and we were like literally on the equator, and it was like, oh, this is so cool. Anyway, there's a little sign. It's like, you're at the equator. Oh, anyway. But I'm sure seeing penguins and ice is also exciting. But anyway, the lone pairs will go on the equator. And the reason is that lone pairs are more repulsive than bonding pairs. Lone pairs are more repulsive than bonding pairs. So if I were to put my bonding pair, say, on the top, on the axis, it would be at 90 degrees with 3 things. Yes? And that's a very close angle. But if I put it on the equator instead, it is only at 90 degrees with 2 things. Yeah? So that's why we put it there. It is at 120 degrees with the other bonds. Okay? And so same thing for the next one. We would put it on the axis. And finally, if we had another one, it would also go on the axis. And then you make a little tutu, and it's just really cute, and you can spin it around and things like that. Okay? So that is the general shape. Trigonal bipyramidal is the basic shape, and then we can go into the other shapes a little bit later. What's this shape? What letter is it shaped like? A T. Guess what its shape is? T-shaped. Yeah? Okay. So very often with these 5 electron domain ones, the shape, we have to kind of turn it so we can see it. Like we have to move it so that the axis is now sideways so you can see the T. Okay. And if we had 3 lone pairs, what shape do we get? Linear. Right? Because when you're looking at the molecular shape, you ignore the lone pairs. And lastly, but not leastly, let's throw just one on here for fun. If we have only one lone pair, do you remember what that shape is called? And once again, it helps to turn this one sideways. So if you're good at manipulating things in your head, what you do is you take it, so you've got 2 of these little things on the bottom. And guess what this does now? It rocks back and forth like a seesaw. Okay, so that's called seesaw. Okay, at any rate, we've got our basic shapes. In the new year, I will be asking you to memorize those shapes. So if you have finished all your gas chemistry and you're like, I need some more chemistry to do over the break, you could work on memorizing your molecular shapes. Or you could not and just wait till the new year. But remember, it is only for central atoms, and it is only in period 3 and below where you can get these 5 or 6 electron pairs around them. And that's because they have a relatively larger size of the central atom. Nitrogen is too small to accommodate 5 atoms, but phosphorus, which is right below it, is big enough. Sometimes you will hear these referred to as hypervalent molecules. I don't exactly know why. Hyper means more, so maybe that's why. The central atom is usually bonded to the most electronegative elements, F, Cl, and O. 11E, the notion of a valence shell containing more than an octet is also consistent. Okay, I'm not even going to talk about this because it's been disproved. They used to think that there was sp hybridization, sp2, sp3.
Is that wrong?
No, this is fine. But then they used to think, oh, when we have 5, sp3d, and when we have 6, sp3d2. The only reason I bring it up is you might come across it in university, but I don't think so. I think they're steering away from that now because this has been disproved. Okay? So we're just going to ignore this and move on to SCl6, and we're going to draw the electron structure for it. And there's nothing new. We have 6 electrons plus 6 times. Chlorine is group 17, so it has 7 electrons. 6 times 7 is 42, plus 6 is 48 electrons. Who will you put in the middle? S. And then what choice do you have with everybody else? 1, 2. And then if you want to do 3, 4, 5, 6, usually we draw it kind of on angles like this. And we'll put a Cl on the end of each of those. Okay? And now you got to do all the lone pairs. Do, 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 do. Do, 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 do. And if you're like me, you get bored doing it, so you hum along with it. Da 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 dun 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 dun. Bum 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 bum. Bum 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 ba da da. Bum 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 bum. Oops. And then we count. And this one is a pain to count like 1 pair by 1 pair. So I'd probably say I have 6 chlorines with 3 lone pairs each. That gives us 6 times 3 times 2 is 18 times 2 is 36 electrons. And then we have 6 bonds, which gives us 12 electrons. 36 plus 12 is 48 electrons. Are we done? Yep. Wasn't that nice? So honestly, these are not actually much harder. You just have to remember that they can do that if they need to. Let us try ClF3. Why don't you guys try that one? Yeah?
Okay. Here. With the CLF, so there we might be there's 7 times
Give it a try. Well, just close it and put a piece of paper over top of it. Look.
No, what are you? I said it. Hey, go 7. So what? So 7 minus 4 is equal. So they all taking 7. Okay, it's crazy, bro. It's crazy. 1, 2, 3, 4, 5, 8. 2, 3, 4, 5, 6. Wait, what? I can't count. 1, 2, 3, 4, 5, 6, 7, 8. 8 times 8 times 8. So we're missing. Why are we missing? So, I'm trying to find it. Stop! How is 2, 3, 4, 5, 6, 7, 8, 10? Oh my God, still they were still missing 2. Wait, another. Yeah, because it's the difference. Oh, so you have to pay half.
We've dealt in the past with 1 or 2 pairs too many. Now we're dealing with 1 pair too few. How are we going to deal with that? Throw our hands up in the air and say, oh no, I am done. I must have done something wrong. Life is terrible. I give up. Or you can remember that chlorine is in row 3. So it can accommodate more than 8. Okay, so check out your central atom, make sure it can accommodate more than 8, that it's in row 3 or below, and then you can say, okay, I got Cl. Instead of having just 1 pair at the top, I'm going to put 2 pairs at the top. So you just add another pair to Cl because it's okay to do that. And now Cl has 10 electrons.
Wait, no, what if you have
do all your other checks. Make sure fluorine only has 1 bond, right? Make sure you don't have any singleton electrons. Okay, and what is your shape here? Feel free to bop back to your where is it? No. So we have Cl. It's got 2 lone pairs, and it's got a bond, bond, bond. What is that? We have 1, 2, 3, 4, 5 electron domains. So go to your 5 electron domain section and go find, you got 2 lone pairs, so go find 2 lone pairs. So that is T-shaped. And you can see if you turn it sideways, it's T-shaped. Yeah? Okay. What have I done? There we go. Okay. All right. How about ICl4 minus? I will say sometimes we get tired of drawing dots. If you write it on the AP exam, draw dots. But if you want to, here's a little trick. Which can be really nice if you're like doing a bunch of them. Do you know what I mean? Especially when you have something like this that has like a million lone pairs. When you're doing it on a test, I would say no. Okay? But when you're doing it for yourself for practice, I would say yes, because it's really irritating to have to draw all those dots all the time. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. 32 electrons. Oh no. I have 2 pairs too few. What shall I do? Add how many lone pairs to the I? 2 lone pairs, because I've got 2 pairs too few, and you can just cram them in like this. Here we go. Yeah? And then you can put brackets around it and your charge because it is an ion. And then I'm going to ask you, what is the molecular geometry? No. That's why I'm saying if you've got some extra time over Christmas, I might spend a little time thinking about that. Yeah, because at some point you're going to have to memorize them all. And we've only got 2 weeks in the new year. So if you're like, yeah, I'm going to devote a little bit of time to that, that would not be a waste of time, right? Like print out a copy and like cut it out and like make little flashcards for yourself. Yeah. I'll make sure, I think that thing is posted, but I'll make sure it's posted on the homework so you can like print it out and make flashcards if you want to. Okay. So what shape have we got? How many electron domains to start with? 6 electron domains, 2 lone pairs. That means that we have 6 electron domains, 2 lone pairs. It's square planar. Okay, so homework over the break, gases, and print and cut up little chart for yourself, or make yourself flashcards on your phone or something like that. I bet if you looked up like molecular shape flashcards, somebody would have them somewhere. You know what I mean? You two have a wonderful break, you guys.